Next, let us see about objectives. These objectives are mainly focused on it. Okay, these objectives are mainly focused on in our case study. First, to utilize the fruits and vegetable waste as a raw material to develop the biodegradable packaging material. In this way, thus this approach both waste management and also plastic pollution at the same time. And then next, to develop the eco-friendly packaging products such as sheet, plates, cups, by using the peel-based biopolymers. In this peel-based biopolymers are provide eco-friendly and sustainable alternative to the conventional packaging materials. And then third one is mainly focus on reducing waste. To reduce the organic waste by converting the waste into value-added product, simply instead of simply dumping them. So normally the waste or goes to landfill. So increasing the environmental pollution. So through this study, we convert the waste into utilization of the product.
India is one of the largest producer of fruits and vegetables. Normally the waste is generated more in processing sectors. Fruits and vegetable processing sectors generate large amount of waste such as peels, seeds and crops. So our research focuses on developing the fruits and vegetable waste into biodegradable packaging. In our research, we have selected 6 major types of fruits and vegetable waste such as tomato peel, banana peel, corn cob, banana bracts to develop the eco-friendly packaging systems. So fruits and vegetable waste, plastic packaging, fruits and vegetable waste packaging reduces the plastic pollution and it will provide a circular economy.
Now we will discuss about production and post-harvest losses. We consider both India and global scenario. Okay, now we will explain methodology. First, collection and preparation of raw material. To collect the raw material from normally available source like industry waste, market, and then raw materials are washed properly and then dried and grounded in fine powders. And then extraction of biopolymers. Naturally, the biopolymers are present in plants such as starch, cellulose, pectin were extracted from the prepared raw material by using the heat treatment and the chemical treatment process. And then prepared biopolymers blended with natural films or plastics like glycerol to form the biocomposite blend. And this biocomposite blend molded under drying under controlled condition, and then after the biodegradable packaging materials are evaluated these properties like thickness, strength, flexibility and overall quality of the final product.
In our research, the expected outcome would be the natural components present in the waste materials will be expected to provide the antioxidants and antimicrobial properties in the packaging materials. From our review, we concluded that the overall product developed from the fruits and vegetable waste should be expected to completely biodegradable.
So finally, I would like to explain conclusion in our presentation. So it mainly focus on in our study to convert the waste into biodegradable packaging material. So it helps to waste and also environmental sustainability. So overall in our study, to reduce the waste and also improve the sustainable environment.
I request the judges to share their questions.
Nice presentation. Can we have some little methodology how you did? Can you explain little bit on that? All the waste you have collected and then what is the methodology involved in that? Yeah, you can say over the mic, please. Pujita, right? Pujita or Lakshmi Priya? Pujita. Yeah, tell from mic.
Ma'am, first we extract biopolymers from fruits and vegetable waste, peels and seeds, ma'am. Next, the extracted biopolymers are mixed with biocomposites such as fibers or fillers to improve the mechanical properties of packaging material, ma'am.
Okay, are you able to get the product finally?
Ma'am,
Not yet, huh?
no.
You're trying.
Yes, ma'am.
How long you're already doing it? How long you're doing it already? Is it started? Your experimentation process is going on? Your experiments are going on right now?
No, ma'am.
It's a theory part. You have theory research now. Okay. All the very best to both of you. Thank you very much. So any questions, sir?
No problem, ma'am. So very nice initiative, because if you see the country like India, we are getting lot of that agriculture waste, we can say residues. It is very high. So the selection of that fruits waste, that is also very, very important, because if you go that sweet lime processing industry, grape processing industry, this biomass is very high. So on what basis you selected your raw material, that is very, very important. Even morning also somebody explained, because your raw material selection will give you very good output of the product. So whenever you select the waste material, you identify what is the cellulose content, what is the hemicellulose content that can be suitable for making this type of packaging material. Okay, thank you very much.
I would like to invite the participants from Department of Food Technology, Powai Engineering College, Powai institutions to present their papers on the topic development of antimicrobial egg trays using copper nanoparticles to enhance egg shelf life.
Lakshmi Priya. Lakshmi Priya. Abhinay.
Good afternoon, everyone. Our project topic is develop. Next. Good afternoon, everyone. Our project topic is development of antimicrobial X-rays using copper nanoparticles to enhance egg shelf life. We are the authors this project. Next slide. First of all, our project abstract is most of all the eggs are important and widely consumed food, but they are easily spoiled due to the microbial contamination during the storage and transportation. Traditionally, eggs are stored in molded pulp egg trays made from recycled paper. These are the biodegradable and low cost, and but they do not prevent the growth of bacteria or fungi. To address this issue, we have developed the antimicrobial egg trays using copper nanoparticles as an active packaging material. Copper nanoparticles are synthesized and coated with the traditional packaging, and then these are prevent the bacteria, and it is the growth of the microorganisms, and these coated trays are made pulp eggs. Next slide. Hey, the introduction, the background of the study: the eggs are highly nutritious, affordable food source consumed worldwide, but they are high perishable in nature. So these are easily contaminated by the microorganisms during storage and transportations, and we are developing the antimicrobial egg trays, and then the problem statement. These are the problem statement of the our project.
So problem statement is nowadays egg everyone to consume. So the transport facility is refrigeration storage. The refrigeration cost is lakhs to 1,000 and 10,000, 18,000 more than. So the cost is refrigeration cost is high. So the egg rate is so high. So we consume the egg is like a nanoparticle synthesized. So it's easily consumed. So easily coated the egg trays. So the low cost and low price. Everyone should consume that, and everyone should export on the farmers. Next slide.
For materials, we have used copper sulfate pentase, chitosan, acetic acid, waste eggshells, turmeric powder, and molded pulp egg trays. For the methodology, we have collected all the waste eggshells and dried it and powdered it, mixed it with turmeric powder, and heated it with water, and the extract is mixed with chitosan, and then it is sprayed using spray dryer on the molded trays, and it increases the antimicrobial effectiveness of the trays. So the shelf life of the egg increases even without refrigerations. Impact. So the impact is we increase the shelf life of the egg even without refrigeration for a longer transportation or storage, which is cost effective, and we have introduced antimicrobial egg trays which reduce the microbial spoilage of the eggs, and the benefit of it is it improves the fresh quality of eggs, and it is eco-friendly and sustainable because it is biodegradable egg trays, and we can reduce the dependency of the plastic-based packaging materials.
So the result is SEM-TEM result. The SEM-TEM is analysis the antimicrobial and the anti-fungal analysis. So E. coli, Streptococcus, and fungal. So nowadays everyone should consume egg. So it's important. Then exported and
cost and the refrigeration cost so high. So we alternated use the egg coated material.
In conclusion, the major outcome of this product is we have observed that compared to normal biodegradable egg trays, our antimicrobial egg trays reduce the microbial spoilage, and it is easy to apply on the existing egg trays. And for practical implementation, it is low cost, biodegradable, and easy to synthesize and apply. For future scope, we have conducted long-term strong studies to extend shelf lives, and it is proven to improve shelf life even without refrigeration for 3 to 4 weeks. So, thank you. Any questions?
Okay, so in this topic, it's a very interesting topic and a problematic statement. What I would like to understand is, do you think, especially in India, in Chennai, do eggs travel in refrigerated container? Do you see that? Do you see that eggs have been transported in any refrigerated containers in Chennai?
Country can't export from.
Okay, if you want to sell your product outside the country, then we can make it as a liquid egg or powder egg. That form of solution is available. What kind of problem you are trying to solve here? That question we need to ask ourselves whenever we are selecting a particular topic. Okay, second thing what I see is, it's good, like it is going to increase the shelf life. But at the same time, the durability of the egg trays to be considered. Because in commercial aspects or in industrial aspects, they used to reuse to a longer period of time. They used to handle it pretty abnormally. They used to throw it, they used to stack above each and every crate. How often, how durable is that particular product? Will it withstand equal to the plastic material? That sort of interpretation needs to be done a little bit detail.
Refrigeration, we are synthesis.
நீ ரெஃப்ரிஜரேஷனோட உன்னோட ப்ராஜெக்ட் நீ போட்டி போடுறோமா?
பயோடிகிரேடபிள் ப்ராடக்ட் இன்னும் இது நேச்சுரலாக வந்து சிந்தசிஸ் பண்ணுறோம். ஸோ இதனால் வந்து எக்குக்கு வந்து எந்த ப்ராப்ளம் இருக்காது. இது வந்து சில்ட்ரன்ஸும் கன்சியூம் பண்ணலாம், அடல்ட் எல்லாருமே கன்சியூம் பண்ணலாம். ஸோ என்னென்னா இப்போ வந்து ஒரு வந்து ஸ்டேட் டிரான்ஸ்போர்ட் பண்ணும்போது ரெஃப்ரிஜரேஷன் வந்து காஸ்ட் அதிகமாகுது. ஸ்டேட்னா வந்து கண்ட்ரிக்கு அது ஒன்று சார். இன்னொன்று என்னென்னா காஸ்ட் அதனால இது ஒன்று ஆட் பண்ணியிருந்தோம். ஸோ இது நேச்சுரல் நல்லா இப்போ வந்து எக்ஸ்போர்ட் ஆகிற காஸ்ட் வந்து அதிகமாக தானே சார். ஸோ வந்து ஒரு வேஸ்ட் மெட்டீரியல் வச்சு யூஸ் பண்ணி பண்ணும்போது அந்த எக்கோட ரேட் வந்து கம்மியாகும். அது ஒன்று. இது மைக்ரோ ஆர்கானிசம் ப்ரிவெண்ட் பண்ணும். இது காப்பர் சிந்தசிஸும் ரெஃப்ரிஜரேஷனோட லைஃப் டைம் ஷெல்ஃப் லைஃப் வந்து ஈக்குவல் தான் சார். கோட் பண்ணி
You need to dig a little more detail.
Yes, sir. Yes,
How much time you are taking already for this?
6 months.
6 months, sir. Able to produce. You have any picture of your this thing packaging material you have there?
Picture.
Ma'am,
paper.
Irka. But what are the properties of the packaging material? How is it now? Are you able to get the copper nanoparticles from that? With all the raw materials, you're able to get it? Okay, little louder, pa. Little louder. Mic la pedinga. Mic pedinga. Yeah. Okay, you're able to make it?
Yes, ma'am.
And what was the shelf life of the egg after keeping in the packaging material which you produced?
3 to 4 weeks, ma'am.
3 to 4 weeks varuda?
Yes, ma'am. We added some turmeric leaf and stems.
புரியுதுடா, பட்
turmeric leaf ஸ்டெம்ஸையும் எக்ஸ்ட்ராக்ட் பண்ணி அதோட சிந்தசிஸ் பண்ணியிருக்கோம்.
ஓகே.
அப்போ என்ன பண்ணால் நேச்சுரலாகவே வந்து டர்மரிக்கில் வந்து ஆன்டிமைக்ரோபியல் வந்து இது பண்ணி அஃபெக்ட்.
அதெல்லாம் இட்ஸ் ஆல் தியரி, ஐ எம் டெல்லிங் யூ. Yeah, but what is in the application work? Are you able to extend that? How do you know that it is extended for 3 weeks? 3 weeks shelf life இருக்கு இந்த எக்குக்கு. How come you know this?
மேம் அனாலிசிஸ் பண்ணோம்.
What analysis you are doing?
Phytochemical analysis, fungal analysis, microbial analysis.
Of the raw materials?
அனலிஸ்ட் பண்ணி தான் மேம் எல்லாம்
Okay, normally egg, how much, what is the shelf life of egg?
5 to 7 10 days மேம்
10 days in a normal packaging.
நார்மலாக வந்து எந்த இதுவும் பண்ணாமல் நார்மல் எக்கோட ஷெல்ஃப் லைஃப்.
Okay, and you are refrigerating this thing? No. You are also keeping it outside with your package. Is the package is 100% covered or something? What is it? Some gaps are there.
ட்ரே மேலே கோட் பண்ணிடுவோம், ஸ்ப்ரே பண்ணிடுவோம்.
Amanda.
அந்த ட்ரே மேலே வந்து ஸ்ப்ரே பண்ணிடுவோம் மேம். அப்போ வந்து நார்மலாக அந்த எக் மேலே வச்சுருப்போம். நார்மல் எக் மேம், எக் போர்ட் கார்ட்போர்ட்.
Okay, okay.
I would now like to invite Bilinda from Department of Food Technology and Dean College of Fish Nutrition and Food Technology, Chennai.
யூஸ் பண்ணிக்கலாமா? ஓகே. தேங்க்யூ. Good afternoon, everyone, and I'm Brinda from College of Fish Nutrition and Food Technology, Chennai. Okay. Okay. Good afternoon, everyone, and my project is based on the utilization of the ZMS COB and Citellus lanatus strain for sustainable parchment paper development. So the growing demand is mainly based on managing the waste, which is mainly produced in the industrial processes, and upon that, where the ZMS which be a further process in order to make a value-added products. In order to make a value-added product to create a circular economy in that, and the methodology and everything is where the raw materials were procured and processed, and they were cast into sheets and they were dried, and the tests like thickness and acceptability tests were taken in order to determine the acceptance of the commercial parchment paper. So not just a plastic makes a pollution in the environment, but also the paper which is mainly produced and dumped in the landfills also create a large amount of environmental impact. You know, and upon that, the baking paper which is mainly used in that is mainly for about 26% of the total landfill, and it creates a large amount of is mainly present in that, which resists the degrading capacity of the paper. So in order to combat those situations, use of agricultural wastes can reduce the impact of in the environment. So So the main objectives are to valorize the agricultural waste into value-added products, and then incorporating them into our day-to-day life to meet out the commercial, and then to minimize the dependence on the consumption of these raw materials. Deforestation. Artificial commercial papers mainly made from the wood pulp. Large number of seeds are mainly required in order to make the commercial paper. So by utilizing the agricultural waste, which is mainly using cellulose content, can make the meat of the problem. And then to assess the suitability of the non to assess the suitability of the lignocellulose receptors for passing chemistry development. By utilizing the agricultural waste in order to reduce the environmental impact. And then to analyze the the main mode of this project is to analyze the main mode of this project is to analyze the thickness and the acceptability test to meet of the consumer preference. And the research start revealing the underutilized waste products, which mainly most of the wastes are mainly used, but the corn crops and the watermelons are underutilized in nature, which are mainly using the culinary purposes for developing the food product and everything. But in order to make into a passing capacity, this is main research process, and also this research is mainly dependent on that. So the materials and methods which I have given, the materials is very simple and it can easily procure from the our homes and also in the nearby local shops, like corn cobs, the watermelon rinds, and the domestic mixture which is mainly used in the large scale processes, and also a seed and also cast into those seeds. And the methodology for this and they were boiled for about 1.5 hours, and then they were pulped in, by using the blender, and the rinds also were cleaned by removing the skin and the remaining flesh parts, and then they were boiled for about 20 minutes to soften the tissues and the fibrous structures, and they were pulped in the domestic mixture separately, and then both the pulps are blended together in the different proportions which I have mentioned in the table, like sample 1, 2 and 3, where the cob and the rind proportion is given like 70:30 for sample 1, for sample 2 50:50, and sample 3 35:65%. And then they are formed as a slurry by mixing with the water, and they were casted into sheets by using the seam by traditional paper making process like decal and mold method, and they were dried in the pashes and drying in order to prevent the shrinkage for about 8 to 12 hours. So this is the result of the paper where the sheets were demolded and they were dried in the sun, and they were obtained sheets. Yeah, the challenges and outcomes of the project is mainly most of the challenges were happened, and among them the most critical one are the crack formation and the brittleness, and also the uneven blending of the pulp, and also the uniform distribution of the pulp. This is mainly due to the increase in the cob, which leads to the which decreases the flexibility, and also it causes the brittleness. And among increasing the rind content, it increases the flexibility of the paper. And sample 3 was shown as a better one in the among the 3 samples. So results and discussion of the project. And among the 3 samples, as I mentioned, the sample 3 was showed as a better one because it contains a large amount of rind content, and that gives the more flexibility when compared to both of the when compared to other 2 samples, where 2 main tests were taken, such as thickness and this acceptability test. The thickness analysis was mainly determined by this using the screw gauge, and this analysis is mainly done in comparison with the commercial parchment paper which is available in the market, and the developed parchment paper show the thickness of around 0.28 mm when compared to the commercial paper which is around 0.05 mm. And then the acceptability test which was made which was done in the 5-point Hedonic scale among a group of people, and then the parameters such as appearance, color, texture, and the flexibility, odor is determined, and we can see that the results obtained in the acceptability test must be met out in order to attain the commercial parchment paper, and further research must be done to make the paper to attain the commercial parchment paper texture. So yeah, further research is mainly done for the optimizing the processing conditions, and like better pulping technique, which I have just used the domestic mixture, but in the industrial purposes they are using the beater and the blender in a large scale purposes, which gives the better pulp consistency. So this is the main parameter, main concern. And then the blending and the bleaching properties, like bleaching in order to reduce the color of the paper to meet the consumer acceptance. And then drying parameters, since you can see that certain shrinkages that has mainly happened in the paper. This is mainly due to the climatic condition, change in the climatic conditions. We can dry the paper and around 28 to 30 degrees Celsius. It will give a better result. But due to climatic changes, increase in the humidity and the moisture content, it reduces the temperature and the. Fine, thank you. Yeah, further research must be done, and the properties mechanical must be tested, and also the application in the culinary field for baking and wrapping purposes is also must be tested.
I request the judges to share their questions.
Very nicely done. Very good.
Thank you.
How long have you been doing this actually?
Actually, it's around 1 to 2 months.
1 to 2 months.
Yes.
Okay. And then why you selected corn cob and then this rind?
Because they are very underutilized things in the agricultural wastes. Since corn cobs and the corn cobs are mainly used for producing the composite blocks in the building constructions only. But in the culinary field, they are not applying in the but it contains a large amount of cellulose content, which is mainly essential for the paper making process. And also rind, which I have chosen, is mainly for the to increase the flexibility of the content. So my main motto is to use just the corn cobs alone, but it didn't give any flexibility. So I have added the rind, watermelon rind for increasing the flexibility of the paper.
But do you think it is enough to make a parchment paper with these two alone?
No, ma'am. I just want to increase like commercial paper. I just want to increase certain parameters in order to meet out the consumer preference also.
No, are you able to get the result actually, like a parchment paper?
I'm doing still. So further research has also been done for that.
Okay. Because application part you have to see, now this is I think the properties may not suit with that of a parchment paper.
Yes, ma'am. But further, by analyzing the properties only, I can able to apply in the culinary field also, like for baking and also wrapping the food products. So that is that application is mainly dependent on the properties of the paper. So upon achieving those properties, I can able to apply in the culinary field.
But that's why I'm asking whether these two raw materials alone may not be suitable.
Yes, ma'am.
Yeah, good. Huh?
Thank you.
Hello, good attempt, ma.
Thank you.
Why you compared your paper with the parchment paper? Because when we say parchment paper, it will be coated with the silicon. You developed some paper, you could have tried with the craft paper. And also,
Sir, because what we use in the culinary field is just the parchment paper only, no.
Yeah,
So for that only, I just compare my developed paper with that commercial paper. So by comparing that, I can able to understand what kind of things I want to develop in that, and I can able to achieve in my further researches. So for that only, I just compared.
for that you could have taken normal craft paper na, without silicon coating. And you are putting thickness is na, it is 3-4 times more than the commercial, because normally they will not do such a thickness. It's similar to like a cardboard thickness it is coming. So that is good attempt. And another thing, whenever we talk about paper, this GOB index, moisture absorption, tearing strength,
Yes, sir.
bursting strength, all these things which has to be calculated. Maybe after, because you are putting in, you will calculate after. Now you are checking only textural properties only.
Yes, sir. Yes.
It is similar
So
to
further, I
our
want
food
to
items.
increase those contents also.
But whenever you are publishing paper, it has to be our paper properties. It has to be there. But the table what you given, it is a normal food item. You will check textural analysis, na? The fracturability, what will be the other things you put it. So this you add it, then it will become a very good paper.
Yes, sir.
Okay.
Further, I
Thank
will
you.
continue my research also. Thank you, sir. Thank
Good
you.
work. Thank you.
Are there any questions from the participants? Thank you.
Thank you all.
Kind notice, please. I would like to make a short announcement. Those who have registered accommodation are requested to submit a Xerox copy of their Aadhaar card and college ID card at the table near the stage during the tea break. I would now like to invite Aparna, Tamilarasi and Vaishnavi Devi from Department of Food Technology, Dhanalakshmi Srinivasan College of Engineering and Technology.
Good afternoon, everyone. I am Tamarasi from the Department of Food Technology, Dhanalakshmi Srinivasan College of Engineering and Technology. I am going to present our research titled with extraction and characterization of anthocyanin from the dragon fruit peel for intelligent packaging. And extract and characterization of anthocyanin from dragon fruit peel and incorporate with starch-based film, making it biofilms for intelligent packaging. And what are the objectives means nowadays people are demanding that intelligent packaging instead of conventional packaging, because conventional packaging focus only just cover the foods, does not maintain freshness, but intelligent packaging maintain the freshness of perishable foods. Our objectives: collect red dragon fruits, collect dragon fruits for anthocyanin extraction, and then extract anthocyanin from the collected dragon fruit peel and isolate the crude anthocyanin from extract and quantify the anthocyanin in isolated crude form and fabricate a film incorporating with dragon fruit anthocyanin to the starch, and we evaluate the antibacterial and antifungal and antioxidant taste and then perform the shelf life studies. Abstract. This study focuses on extracting the anthocyanin, and anthocyanin is a nature and water soluble pigment and is highly pH sensitive. When we make it as a film, we can visibly notice that food is get spoiled or not due to the change of pH. When we wrap around the example meat, when we wrap this film around the meat, it will change the color like green due to the pH sensitive. And we using anthocyanin were extracted using the methanol soaked filtration method, and then isolate them and absorbance through UV spectrophotometer at 510 nanometer and 700 nanometer. 510 nanometer shows at this wavelength the anthocyanin shows high concentration, and 700 nanometer shows the absorbance of any interferences in antibodies. So we can subtract them and to determine the exact content presence. Research flow: dragon fruit collections and extraction of anthocyanin from the peel and isolation of crude anthocyanin, and we quantify of anthocyanin content and fabrication film, and then evaluating the antibacterial, antifungal and antioxidant test and shelf life studies. First, materials. And dragon fruit were procured. Its scientific name is Ailosaurus costaricensis. And then sample was we take anthocyanin dragon fruit peel, 240 gram of wet fruit peel, and kept at outer oven at 45 degrees Celsius, and then grind by using spice and herb grinder, and dried fruit peel powder. Extraction of anthocyanin, adding 2 ml of 1% glacial acetic acid in methanol to 0.5 gram of dragon fruit peel powder, refrigerating for 24 hours, and then decanting the supernatant. Refrigeration for 24 hours, it prevents the degradation and maintains the stability of color. Anthocyanin was extracted via methanol soaked filtration method. Isolation of crude anthocyanin. We take two different pH buffer. One is 1.0 pH buffer and another one is 4.5 pH buffer. Dilution to find the dilution factor of anthocyanin, and at 1 pH buffer it shows anthocyanin shows high concentration, while 4.5 pH buffer shows low light concentration. So pH 1.0 is determined, and then
I am Aparna from the Department of Food Technology, Dhanlakshmi Srinivasan College of Engineering and Technology. Next one is fabrication film. Fabrication is a process of formation of a film, and the film is formed using starch and 1% of glacial acetic acid. The starch powder and sample anthocyanin extract and glacial acetic acid stirred using magnetic stirrer and poured into a petri dish and dried over 24 hours for 37 degrees Celsius. And next, antioxidant test. Antioxidant test is carried out using DPPH assay. DPPH assay is a natural pink and purple color which can turn into yellow color in the presence of antioxidant. So the antioxidant test is carried out using DPPH assay. This is the result. Total antioxidant assay activity is determined using 3 reagents: sulfuric acid, hydrogen phosphate and ammonium molybdate. These reagents are mixed at these concentrations and with 1 ml of distilled water and 1 ml of sample. The results was shown, which is incubated at the temperature of 90 to 90 degrees Celsius for 90 minutes. The observance is measured at 695 nanometer using UV visible spectroscopy. And antibacterial activity. Antibacterial activity is carried out using agar well diffusion method with MH agar, which is molybden Hinton agar, and which is trained using E. coli. Antifungal activities carried out with PD agar, potato dextrose agar, and which shows low results than bacteria, antibacteria. Shelf life analysis using chicken. Chicken is a highly perishable food and which also contains high protein, so we use it as a experiment. One chicken is wrapped with the anthocyanin film and another is left uncovered, and the results shows 24 hours of non-spoilage, which shown the result is shown as change in color due to the pH change in a chicken. The pH change results in color change like yellow. The normal chicken contains pH of 5 to 6, and the spoilage results in the pH of range 8 to 9. So it's the anthocyanin color change up into yellow color. The results shown: the extraction and characterization of anthocyanin from the dragon fruit peel was successful.
I request as judges to share their questions.
Very nicely done. Presentation is good. First of all, I want to ask you why you chose anthocyanin from dragon peel.
Everyone choosing our own vegetables and other, we choose that from dragon fruit, and we like dragon fruit.
You move inside better.
Everyone just focusing on vegetables, so that's why we choose the dragon fruit peel. And anthocyanin contains high antioxidant level, so antibacterial.
Yeah, that is all there. But why you choose dragon fruit first? Okay, you that has more amount of this thing. Okay, what other ingredients have used there? Other than starch, 2% solution you have mentioned,
2 grams
and then some salt, 1%, I think, na?
Acetic acid.
Glacial acetic acid. Okay.
Methanol.
Are you able to get a film out of this first of all?
Mixing of starch and glacial acetic.
When dried, did you got a this thing film? You are able to get a film,
Yes, ma'am.
and the film is able to wrap a meat also. You are sure about it or not?
It's just working.
See, 2% starch solution is very small. Yeah. How can it form a film? And then that film, okay, you can take it up, but how will you wrap a meat and then? You did it? How many times you repeated it? Your idea is right. Sorry.
3 to 4 times.
3 to 4 times you did.
But we could not complete it
We
properly,
trying-
ma'am.
Sorry, but little louder, please.
We could not get properly, so
Proper. Yeah, that's what I'm asking you. Were you able to get a film, or you need to add some other ingredients to make a
just
film?
working on it, ma'am. But idea is making film, but
Yeah, but you need
have
some other
to
ingredients.
refer more and, proper.
Yeah. Okay, and then another point is, why are you seeing DPPH and all there? DPPH, you have done some properties, this thing, na? Radical. You are seeing for the antioxidant properties, now you're seeing, na? For the film, you are seeing, or you're seeing for the anthocyanin. What are you seeing this for? I saw you doing DPPH assay. For which you did this? You did this for the
Anthocyanin, ma'am.
anthocyanin. Why should you need to do that? Because it's already proven. Anthocyanin from dragon fruit is having good DPPH. This scavenging activity is very good actually. You don't need to do this. You should focus more on the film properties.
Okay, ma'am.
More on the permeability, migration, all these things you have to focus on this. Okay, which is a proven thing you need not do. Making a film is more important for you.
Okay, ma'am.
Okay. And then you want to make it on the meat, right? Meat you want to. And meat, what is the shelf life?
just 24 hours.
5 to 6 hours. 5 to 6 hours.
How many hours?
5 to 6 hours in the
5 days. And how much time you are able to extend it?
It indicates the freshness of a meat.
Meat.
Does not prevent the spoilage.
I think you have taken a very tough job actually, I think. Meat is supposed to be the most critical one because it's open. Now, you don't have any cellular structure intact in that meat. And then when you cut it immediately, it's high protein. High protein, high moisture, and then it will get spoiled very faster. 3 hours itself is high, I think. I think maybe 1 or 2 hours in an ideal ambient condition, room condition. So 12 hours is not at all possible. I think you get 12 or 24 hours you gave.
24 hours.
You need to repeat it really.
Okay.
Form the film properly.
Okay.
And then maybe meat means you need to be really very careful on this. Because anywhere you go and present like this, they will ask a lot of questions on meat.
Okay, ma'am.
Okay?
Thank you.
Thank you.
Good, huh?
I would now like to invite K7, Nitish Kumar and Raja Paratoshi from Department of Food Technology and Dean College of Fish Nutrition and Food Technology, Chennai.
So good afternoon everyone. I am Nitish Kumar and he is Kesavan and she is R. Rajavishwi. So now we are here to explain our project in the title of Cell to Self Bioplastic, development of bioplastic with the help of chitosan polylactic acid and incorporation of rosemary extract to it. So let's start with the abstract. The use of petroleum-based bioplastic in food packaging increase the environmental pollution and it is take long term to degrade, so it's affect our environment. So we came up with a solution of developing a sustainable packaging material with the help of chitosan and polylactic acid incorporated with rosemary extract. And chitosan is extracted from the crustacean cells with the help of deacetylation process, and polylactic acid is incorporated to it along with rosemary extracted is also incorporated due to it contains more amount of antioxidant and antimicrobial properties. So the developed bioplastic is good in mechanical strength, physical properties and antioxidant and it is eco-friendly and it can degrade within 10 days. So let's talk about introduction. In India, about 3.5 million tons of plastic waste are generated. When we compare with global, it's around 400 million tons by end of 2024. By 2025, it is increased to 430 to 516 million metric tons. Only about a small fraction of 9% is recycled, and about 6 to 8 million tons of scrap or as a waste are generated. By considering all these concerns, we have developed a sustainable packaging material with the help of chitosan, polylactic acid and incorporated with rosemary extract. So chitosan is derived from crustacean cells by deacetylation process. It is biodegradable and biocompactable and it can be easily have the film forming ability. So polylactic acid is incorporated to it because polylactic acid has good mechanical properties, high stability and heat thermal properties. It is a bio-based thermoplastic polyester, and rosemary extract contains antimicrobial and antioxidant properties. Antioxidants like cursolic acid and rosmarinic acid. So next objectives: to prepare a sustainable bioplastic with the help of a polylactic acid, chitosan and rosemary extract, to test it for acceptability, biodegradability and mechanical properties, physical properties and barrier properties, and to compare with conventional plastic which is available in the market. And the research gap: to develop a bioplastic using chitosan, polylactic acid and rosemary extract. And the mixing and bonding between the polylactic acid and the chitosan is not well given in any research paper. And the effect of rosemary extract on the biodegradation of the polylactic acid chitosan film is also not clearly explained. So the materials records are crab shell, HCl, sodium hydroxide and rosemary leaf, distilled water, chloroform and glassware and hot plate. So to prepare rosemary extract, for 100 grams of leaf, we have added 200 ml of distilled water. Then it is heated, then the filtration process. Then the filtered juice is centrifuged at 10,000 RPM for 10 minutes, and it is we obtain the rosemary extract. So preparation of chitosan extract. The crab shell powder is taken and the demineralization process is done for 1-normaltic HCl, through which we can break down the calcium carbonate, and deproteinization is done to break down the protein components or ammonia groups, and deacetylation is process done because the chitin which contains acetate group, so deacetylation broke down the acetate group and we get the chitosan powder. So the procedure for preparing chitosan polylactic acid film: 1 gram of chitosan is added to 100 ml of water which contains 1% acetic acid, chitosan suspension, and 10 ml of chitosan is prepared. And for PLA solution, we have dissolved 10 gram of polylactic acid in chloroform. So PLA solution is prepared. We have added 10 ml of chitosan suspension in 20 ml of polylactic acid solution. And 1 gram of gelatin is added in 50 ml of distilled water. Then it is heated along with 3 ml of rosemary extract is added to it. Then the prepared 10 ml is poured into a glass plate and it's spread even in the room temperature. We have obtained the chitosan polylactic acid bioplastic. So next, cost estimation. For preparing 10 centimeter into 10 centimeter of film, it takes about 67.12 rupees, which may be very high when we see for about 10 centimeter. But when compare with the large scale, it will be about 1/10 of the cost. It will be around 6.7 rupees when it is go for large scale. So the discussion, we have done the test against our film. The density of the film, and the density is calculated by mass area thickness method, and we have taken two samples. One is our formulated film, that means chitosan polylactic acid film, and the another is conventional available LTE films. So for the control sample, the density is about 5 gram per milliliter, and for our sample is 20 gram per milliliter. Then the moisture content, for the moisture content in conventional available LTE film, it's about 40%, and our is about 0% because PLA do not absorb or gain waters. Then solubility test, it was done against 4 solvents: ethanol, acetone, chloroform, and distilled water. PLA naturally dissolves in chloroform, so our bioplastic has been dissolved in chloroform. Water absorption test, in this control sample and our film did not absorb any water after 24 hours of soaking it. Then the mechanical properties and the film thickness, and the control film is about 320 microns and our film is about 15 microns. Then biodegradability test, naturally LTP film do not biodegradable easily, but our film has been taken some days to dissolve. It takes 10 days to biodegradable naturally. Then acceptability test, we have created a scorecard and circulate among our students, and we have gathered this information against the parameters like appearance, texture, odor, overall acceptability, and these are the ratings they have been given.
Now we talk about application in food packaging. First we talk about active food packaging. It's mainly during storage it releases the antioxidant and antimicrobial properties. Next is it's used to package for fresh and perishable food like fruits, vegetable, meat and seafood products. It is edible and biodegradable application. It is improve the food safety. It's mainly prevent the contamination by pathogenic microorganisms like E. coli, salmonella, etc. It is eco-friendly and packaging solution. Next is it is modified atmospheric support.
And next one is the economical benefits. When shell waste is converted into the value chitosan, it can increase the probability of the seafood processing, and it can minimize the shell waste disposal expansion. Support the economical practices. Instead of the costly chemical preservatives, we can use the natural rosemary extract. It can improve the market acceptance of the packaging film. And finally came to the conclusion, the major outcomes. The PLA provides a good mechanical strength, and chitosan impact the biodegradability, and the rosemary extract enhances both antioxidant and antimicrobial properties. And practical implementation, these packaging films are eco-friendly and alternative to the conventional plastic packaging, and it reduces the dependency of the synthetic preservatives in support of the waste management and environmental production. And the future scopes, we improve the mechanical barrier.
And this is the PLA film we have been developed from our institute. We have a prototype. We have been developed.
How many months you are doing it for?
4 months, ma'am.
4 months. Can I tell something about nitrogen? What are the different components?
Ma'am, PLA takes about normally it takes about months to degrade in our natural soil, ma'am. But when we are adding chitosan to it, the degradation process boosts up, ma'am. So because PLA has a natural anti-microbial activities itself, ma'am. So it boosts when the PLA and the polylactic acid and chitosan are combined along with rosemary extract antimicrobial activities. It can be boost the biodegradation power, ma'am. but we have some limitation while adding chitosan, ma'am. It reduces mechanical properties little bit. We haven't tested. First, we have made a PLA film, ma'am, which is a purely PLA film, and we have done for elongation, strength, and mechanical properties, thickness. Everything has been done, ma'am. But when we adding chitosan to it, the degradation process is very faster than we compared, ma'am. But mechanical properties are being little reduced, ma'am.
Yeah, show the tabular column. How you your results. Can you show your results?
Result we have made this one.
That's very important one. Na? You should show that, na? Because we want to see the exactly how much percentage you have used each thing, and then what are the results actually, the properties of that this thing, film, everything.
We have made this much only.
That is more important to see from our point of view. Yeah.
Yeah, it's a really good attempt. So here you first developed the PLA film by casting method separately. Then you applied as a coating this raspberry, or you made a mixture with a different ratio. Then you
plan to develop chitosan and polylactic acid film only, sir.
Okay.
But we have an idea of making PLA film alone for. We can have that as a control sample. We thought, sir, first.
Now, what I want to tell you, already PLA granules are available in market.
Yeah.
Then you can buy it, you melt it, make a film.
Sir, but
then you can apply as a coating this raspberry.
But our thought is to replace the conventional plastic which is available in our local shops.
Yeah, it is understandable, but if you see the cost wise, na.
Yes, cost wise it is.
You are saying 67 rupees for making how
10
much?
centimeter into
10 centimeter. Then our intention of that packaging itself, we have to minimize the cost of that packaging material, and it should be energy efficient. No? So in such a case, that is the one thing. Just to idea, because you can buy that granules and melt it, and just you can apply as a coating. So that is another method. You can minimize the cost. So that can be applicable. And you study any antimicrobial properties with a different microorganism like Staphylococcus,
we have
E.
didn't done
coli.
any microbial activities.
Okay, because that DPPH assay, that microbial, that is very important, because when you claim it is antimicrobial, so that is the thing. Otherwise, good work. Thank you. Your film also very nice. Okay, because it is a casting method, but if you make something like industrial production, because that is the one issues in our country. All biofilms what we are making in our laboratory, it is a casting method. Petri dish, 10 by 10, one plate will be there. There are some China company, they are making some YouTube you can see, but that is also how it is materialized, we don't know. But if you develop the machine, converting this biomass into a continuous production film like axial blown method in a conventional plastic, then that will catch up the market. Thank you.
Are there any questions from the participants? Thank you. The results of the paper presentation will be announced after the tea break. Kind notice please, I would like to make a short announcement. Package competition will be conducted at the Department of Printing and Packaging Technology. Registration is on spot only. G-form registration has been closed and each team must consist of 2 to 3 members. All the required materials will be provided at the venue. This competition focuses on prototype package design and it is not based on the graphic design. The package design is based on the on-spot theme. As of now, the participants who has registered are S. Pavitra, S. Kalishwari, Kesavan P. Nitish Kumar, Raja Pratoshi from College of Food Nutrition and Food Technology, and Riti Ponmarani, Suguna, Kartika, Chinmayi and Pavitra Devi from College of Engineering, Gindi. Once the tea break ends, you guys might wait At the entrance of the Raman Auditorium, student volunteers will help you to guide throughout through the way to our Department of Printing and Packaging Technology. Those who are interested now can register also. We now invite all the participants to proceed for the tea break, which has been arranged at the space adjacent to the Raman Auditorium. Thank you. And I also request everyone to reassemble in the seminar hall by 4 o'clock. Kind notice please, I would like to make a short announcement. Those who have requested accommodation are requested to submit a Xerox copy of Aadhaar and college ID card near the table, near the stage during the tea break.
I want to say everybody has done very nicely, equally very nicely. And I want to congratulate everybody here who has done the work. Yeah.
Okay. One more, just let's take it as an advice or something else. Before trying to do some research or you are trying to solve some problem, just check the affordability aspects. We as a student, when we are studying, we will be more on doing a research in different aspects. But at the same time, it should be commercially viable. If it is not going to be commercially viable, all your efforts and everything would still remain in your college shelf as a research. It would not be helpful for all the real users. So think in that aspects and build something which is commercially viable. Please note this always, whatever research topic, whatever it is, just think it should be commercially viable.
And to add some more points in this, I just want to add one main point that certain topics which we have covered, some of the groups, we found that it is not actually practically done. I'm telling openly, but see, you have to, in these days, you have to, ideation alone is not important. You have to do it in an experimental way. You have to see whether you're able to get a proper pack, any film or whatever thing you're able to get it. So unless then only you can come and present. Okay, this is one major thing we saw in some of the groups. They have done this. But of course, everybody has, the ideology is very nice. Everybody has done very nicely. Presentation is also very good. And we are happy that we can see people coming on the stage and talking boldly. So this may be a starting first time or second time for you, but it's good that you have come out like this. So it's not, it doesn't, don't need to think that who is a winner in this, okay? Whoever has participated, everybody, it's a great credit for all of you. Huh? Okay, but finally we have to give for one team. So excuse us for selecting one team, but that team is also very good. So we cannot avoid this because it's overall not from us two, it's from all the whole team, from the here the presenters, from the guest. Everybody has selected this topic. The topic is shell to shelf bioplastics development of chitosan PLA based sustainable packaging material by Keshavan, Nitish Kumar and
Raja.
Actually your marks are very close by, so difficult for us to judge it, but it is a unanimous decision. It's a unanimous decision from all the guests. Yeah.
With great enthusiasm, I invite our next speaker, Dr. S. Ananda Kumar sir, a distinguished academist and researcher with extensive experience in the area of food science, food processing, and food packaging techniques. Sir has been actively involved in teaching, research, and professional engagement, contributing to the advancement of food technology education and industrial-oriented research. Sir's professional interests include food quality and safety, packaging solutions for food preservation, and sustainable approaches in food science. Through Sir's academic and research career, Sir has contributed to scholarly publication and has involved in collaboration activity linking academic with industrial needs. Today, Dr. Ananda Kumar sir will be sharing Sir's insights on the topic of contemporary relevance in the domain of modern food packaging and processing technologies, contributing to the broader discussion of innovation and sustainability at MTIFP 2026. Let's put our hands together for welcoming Dr. S. Ananda Kumar sir.
So very Good evening, one and all present here. The organizing team and delegates from different academic and industry sector, and my dear students. So I am very happy to see many of your presentations, and really it is needed in our country to develop such a good packaging materials that can be supportive for the food applications, because if you see the non-food material, okay, so you can develop some film, you can apply for some automobile industry or other thing, they will have regular shapes. But if you take our agriculture commodity, it is a heterogeneous. Even you buy potato in the market, each potato will have a different shape and different size. And customizing a packaging material for this type of commodity, it is really challenging. Otherwise, other materials you will make uniform. You take pharmaceutical product, you take any other non-food items, you will have a perfect design shape. But our agriculture commodity, it is very difficult. So we have many challenges in front of us to standardize this packaging material. So in such a case, also if you see in our country, very few group of people working in the packaging. Particularly in that, if you come downstream, food packaging, that is also very, very less. Even I discussed with the sir also, even IIP Chennai is there. They are also offering a PG program. IIP Mumbai, they are offering. Ahmedabad, they are offering a PG diploma in packaging. But if you see, they used to say in 1987 they started, but so far the number of graduates come from IIP, it is almost some 8,000, 9,000. See our population strength and the number of packaging engineer in our country. So that has a very big differences. So I request the student participants and researchers, academicians, there is a very big gap in this area. You can do many wonder of things. Even you take any packaging material that's patent, this Japan will have more patent, particularly this active packaging, intelligent packaging, that UK, Japan, they are all having more patent. This China, they have many patents because they are using many processed food items. But in our case, all agriculture material, we are getting very fresh materials in our market. So here this research area is very less. So in such a case, you can think of it. So here in this area, this topic, just I want to share my experience, particularly with what we are working in the sustainable packaging, particularly by using this 3D printing and nanotechnology. And what are all the challenges we are facing, what are all the outcomes we get it from the different grant aided project, that I want to share with you. Down, up, down, yeah. Okay. So this 2015, we started this UN announced the sustainable goals, and many people we are all working on it, making a green technology, green processing methods, all these things, and how the earth is revolving. Similarly, the word sustainable also we are using in many forums, and many sponsoring ministries supporting sponsoring many projects. If somebody come up with developing some green technology, green packaging materials in different applications. But if you see, even those days, 10, 15 years, if you see any packing material, if you develop, but they will not do the complete evaluations. Complete evaluation means what will be the biodegradation level, what is the greenhouse gas which will be comes out. So these are all the things not coming, and what will be the energy usage in the development of that particular packaging material. So these are all the things we didn't include in our studies. But now if you see the life cycle analysis, circular economy, all these things which is coming into the packaging system. Even if you see the minimizing the packaging materials in the existing pattern, that is also in another way we are working on it. if you see maybe some 5-7 years before, when we buy the chocolate box or something, we are using that roll-on flare-proof cap. You have to turn the cap. So the height of the caps, closures, the thickness, it is higher. But nowadays you see there is no such a closure type of, okay. So just to push up and you can lid open it. So that type of things are coming. So nowadays that recycle, reusable, minimizing the plastics in the industry, all these things are coming in the industry. So in such a case, you have to develop the packaging material which has less energy consumption, and also it should be environmental friendly. That is very, very important. And even the sustainable food packaging, okay, there are even Morning Machesari clearly differentiate what is bio-based packaging material, what is biodegradable packaging material, because we also compostable packaging material, we are saying edible cutlery, we are telling tableware, there are different terminologies we are using it, and peoples also they are confused which one will be the biodegradable materials or what will be the bio-based packaging material. So whenever you develop some packaging material, by adopting some of the methodology or testing procedure, then you can claim it is a biodegradable packaging or non-degradable packaging material. That is very, very important. And another thing, whenever you select the packaging material, you first find either it is needed or not. Okay, that is the minimizing the usage of the plastics. Okay, for example, this slide, is it needed to pack individual banana in a individual plastic cover? Because if you keep the banana, because it is highly respiring commodity, it will produce ethylene very faster. Even you buy some mangoes, unripened mango, you just keep one ripened banana in the mango box, you close it. Next day you just to open the mud pot or something where you keep the mango, this mango will start ripen because this banana will produce more ethylene. Respiration rate will be very faster. So if you pack individual banana in a plastic, or what will happen? It will produce more carbon dioxide. Your banana will spoil within a day or next day. If you keep it in open atmosphere, it can come 1 or 2-3 days also. Just to make the branding to popularize in the public, the people they are unwantedly packing and they are adding cost to the consumers also. So you minimize the usage of packaging materials where it is needed, that you use it. For example, when you buy this dark fantasy biscuit, so those days when you open the biscuit packet, you have to consume all. You can't keep it. It will become absorb the moisture. Okay, the crispiness will go down. But now they are making individual biscuits will be packed primarily packaging material. So where it is needed, there you can use it. But where it is not really recommended, then you please avoid such a usage of those packaging material. That is the one point you can support the environment. And these are all the sustainable packaging materials. Even morning some sir also said, okay, this paper 80 to 85%, and metal we are using some 60-40%, and plastics also we are using it. So these are all the materials, it's plenty we are available. Even in the paper also we have, when we talk about that food packaging material, that virgin pulp we are using it for the food direct contact food applications. But the recycled paper material, you can use it for making a secondary packaging material or tertiary packaging material that can be used for transport purposes and handling purposes. And glass, as I told you, it is also a inert material. Okay, this melting point also, it is very higher. It is very safe. Only the problem will be the handling will be the issues, and the empty weight of the container will be higher. And also cost of the packaging material when compared to plastics and it is very high. But it is also we can claim as a sustainable packaging material. Metal containers. So whenever you go for this thermally processed food item, whenever you want to extend the shelf life of the commodity more than 6 months, okay, then this is the one option, metal containers. Either you can use tin container or tin free steel containers,
or electrolytic chromium coated steel containers. So that will support. So here only you have to standardize the pressure and temperature of your retard processing method, then you can use it. So this also which will comes in the sustainable packaging materials. Next we are coming to this biodegradable packaging material. So as morning Rajeshwar Maches said, as per the definition, by using that microbes, when you are degrade, we can claim it is a biodegradable packaging material. But some of the packaging material, it will degrade when there is the presence of oxygen. Some of the packaging material which will degrade when you put it in the water, that will be called degradable packaging material. Similarly, some of the things which will be exposure to the lights, then it will start degradation. So you understand the definitions of different degradation process. That is also very, very important when you select some packaging material, or when you develop some packaging material for some food applications. So this category, it has to be fulfilled. So this we attempt in our institute, developing a biodegradable packaging material by using that PLA granules, and that can be used in the food application. What kind of quality we can maintain, that we evaluated. So here we selected that PLA granules, and we compared with polypropylene and low density polyethylene granules. We developed the film with a different thickness of the packaging material, 50 micron, 75 micron and 100 micron with the axial blown method. And these packaging materials, we tested these mechanical properties, barrier properties, as well as that is sealing properties. So when we say these bioplastic materials, the first thing is the cost of that bioplastic material is very high. 1 kg of that PLA granules cost is 400 to 600. But 1 kg of polypropylene or polyethylene granules, 170 to 200 rupees. So first drawback what we are facing is the cost of the packaging material. And another thing, if you see the mechanical properties, strength, as well as that physical properties, if you see, this PLA, it's not matching with the conventional, because in conventional plastic you can create the transparency packaging material, PP, LDP you can see. But if you see that PLA based packaging material, the transparency value, it will become opaque in color. People, they want to see internal product quality, the colors. So, but here you can't see the transparency similar to our conventional plastic material. And another thing, once you buy the lot, PLA granules, you have to use it in 3 months period. When you store that PLA granules, it will absorb that moisture. Then when you put it in the axial blown machine, you will not get the continuous flowing of the packaging material. So that is the another drawback we faced. And even after producing the packaging material, immediately you have to sell it. You can't store it as a conventional packaging material 6 months or 1 year, because it will become brittle in nature. So these are the drawback we are facing. So, but this we tested with other functional properties. For example, this using SEM and TEM, and you can have these bioplastics will have similar smoothness surfaces, same as it is like what we can say PP and LDP, but you can easily identify these machine directions and as well as that cross direction in PLA based packaging material when compared to other conventional packaging material. And also if you see the melting point of these packaging materials, okay, so there is PLA based packaging materials, it has the melting point starting from 100 to 120 degree, but this LDP and PP will have this melting point 140, 160 degrees centigrade. That is also varying with that thickness of this packaging material. And also if you see the functional properties, this FTIR value, and this also will have that weak bonding structures, that PLA. So because of the polymer breakdown, the strength and stability of the packaging material, it is lesser when compared to that PP, that polypropylene and low density polyethylene materials. And here we want to adopt this developed packaging material, use it in the food applications. Mainly if you see in our food industry, the snacks food industry, if you take, mainly they are using the plastic material, laminated pouches or co-extruded film they are using in the snacks food industry. It is very easy to use it. So in such a case, what we did, we newly prepared that potato chips and we packed
with MAP, nitrogen flushing, without MAP also. With bioplastic packaging material, what we developed with the different thicknesses, same thicknesses what we developed with PP and LDP, there we have tested. So here if you see the properties of these developed chips, okay. The first thing is when we say the chips, so it should be the crispiness. When you just break it, that sound has to come, the powder form that has to be spilled out, okay. So in the bioplastics, when we store, up to 12 days it was okay. After 12th day, it started absorbing the moisture. It started slowly absorbing the moisture. After 12th day, the crispiness has gone down. But this PP and LDP, it has the very good crispiness, which means that bioplastics will have the lesser, what we can say, more water vapor transmission rate. So it started absorbing that moisture, that type of things. And also if you see that oxidation, fat oxidation is taking place, and what we can say, you can have off odors. When you open the packet, that potato chips, that flavor sensory value also has gone down. So we conclude up to 12 days you can store the product in the bioplastics, but you can keep it for up to 25 days or 30 days in the conventional packaging material. Again, if you fill that nitrogen gas, so it can come up to 45 days in the conventional plastic materials. And this gas barrier properties also, it is lesser in the bioplastic materials. And another thing, we pack these materials for this wheat flour. This is another area. All rice flour, wheat flour, all we are packing in the plastic materials only. So we tried what will happen to this type of things. Okay. So here another absorption, that moisture absorptions will be that all our the dry materials which will become clogging. Even sometimes we observed the insides will make puncture in the bioplastics, and that will get entered, particularly that tribolium, castaneum, that insides, what you are seeing in the wheat flour, insides will come. So that inside easily it can make puncture this bioplastic film, and it can, number of population denser will be higher in the materials. So here also if you see around 25 days or 30 days you can keep it. If you keep it in dry place, this bioplastics will retain this quality. And when you check that gluten content using the farinograph, that amylopectin in the wheat flour, so that also creating the decreasing trend. And what the flour we stored in the bioplastics, when you make the dough, and the chapati quality is not coming good similar to the. So these are all the problems it is there. But limited period, 20 days or some up to 25 to 30 days. So that you can use it for this type of bioplastics. It will normally, if you buy the wheat flour in the market, they will give 3 months shelf life. You buy any wheat flour in the market, you check the expiry date, always they will give 3 months. So that is the another issues we identified. So to improve that functionality of this packaging material, so we tried another bread. Okay. So normally the bread they will give 3 to 4 days only shelf life. Okay, 2 to 3 days in the bakery shop they will give. Otherwise, if you go this modern bread, their processing method will be different. So they will give 2 weeks, 15 days, 20 days they will give shelf life. So here what we did, we added these ethanol emitters into the system. So when we make this microbial free environment, and that time it was supporting the extension of the shelf life up to 5 days. Without that, you have to keep it within 1 day you can sell it. So conventional plastics you can use 1 or 2 days for selling this product. So in such a case, making the packaging film, making this active composition, then that will support you your shelf life extension. But again, it is the addition of cost. Okay. So these ethanol emitters, what we made, it is 1 rupee sachet only. So we prepared the ethanol emitters in our laboratory. We made different concentration, 50, 60, 70% of ethanol emitters. Then we evaluated. So in that we can use it around 50 to 60%. It's enough to make this type of pouches, and it can be added into the packaging systems. Another area what we are working in the biodegradable packaging materials, or we can say it's a tableware. This mycelium based packaging material. So in our country, if you see, it's an agriculture country. We are producing around 350 million tons of food grains. But if you see the agriculture waste after harvesting crop, we are getting around 700 to 800 million tons of agriculture waste material. It can be paddy straw, wheat straw, stalks, leaves. Somebody presented that corn cob. These are all the things which will be called waste material. This we are getting 600 to 800 million tons. So we have very good biomass in our country, and this biomass normally they are using it as a fuel. For energy purpose they are using it. And in Delhi, these are all the issues. You can see that during winter time, totally the environmental will be fog, even transportation will be affected. So converting this type of agriculture waste material biomass into the packaging material. So this is another study we taken. So to get the cellulose and hemicellulose, we tried with a different alkali treatment, and we made this mycelium based compostable packaging material. Because we need alternative to thermocol, because in our country thermocol also now many people they banned it, and applications in the food also they minimized, particularly the fisherman, that ice box for catching the fish, the fisherman has to take the ice. So for that only we are recommending insulated box. So otherwise minimized the usage of the thermocol. So this mycelium based, so we extracted this mycelium from the button mushroom as well as from the sorghum. So this extracted mycelium we added into the biomass material, and we cultivated in the laboratory conditions. So based on the packaging material design, you can make any dye. You can add the mycelium with the ratio of this biomass with the mycelium. So normally 1:2. So you can take 1% of mycelium and 2% of your biomass. Then if you keep it in 15 days, you will get the compact mycelium based product, and that can be formed in a particular shape. And even you can see this contact angle is very good. It will not absorb that moisture. Even it has that fire retardant. So this type of materials you can make such a packaging material. It can be used as a primary packaging material or secondary packaging material, which will have a very good cushioning effect. So you can use it in the transportation purpose also. Another interesting area, the food industry waste. Okay, the food industry, for example, if you take the rice mill, rice bran is the waste material. They will give it as an animal feed, particularly for the poultry industry. After removing that rice bran oil, the defatted rice bran, they will give it in the poultry feed. Okay, so and some people they will make rice bran biscuit because it has more fiber. Some industry they will use the rice bran for making biscuit and cookies. That is also taking place. So what we did after defatting this rice bran oil extracted, so this defatted bran we can convert as this packaging material. That is another area we are working on it. We got the raw material from this Dindigul Naga wheat milling industries there. From there we got the mill, and our area is Tanjavur. There are many rice mills are there. So we got the rice bran from those industries, and we started working on developing some tableware from these materials. And this is the setup what we have: this flour mixing unit, and a dough kneading unit, and a dough cutter, and as well as the hydraulic pressing cup making unit. Okay, so all these things which will come around 7 to 8 lakh rupees only. So somebody interested to convert this biomass material into plates or cups, that is the one area you can use it. And this is a small video, you can just that 1 minute, you can see how this process will be there, so that you can also, somebody interested, you can work on it. So here what we did, we taken that defatted bran and we added that starch. Okay, this composition you can take 60% of the bran and 40% or 70% of the bran and 30%, and you can add some gluten powder also for the binding. So once you add water, like our chapati dough making machines, you can prepare the mixture. So after that we are putting into the dough cutting machine. So here, what is the cup size you want? You want to make the juice cup or tea cup, or you want to make any plates. Okay, based on that you can cut the material as per your quantity. So after that it will be transferred to the hydraulic pressing machines.
So here it has the sensor, there we can differentiate the weight, how much quantity you want it. So here these hydraulic pressing machines, you have to set the temperature and pressure for making such a cups, and you have to give the exposure time, that heating time. So normally we used to play with around 170 to 200 kg per centimeter square, and the temperature will vary with a different raw material. That is also from 180 to 250 degrees centigrade, and the holding time will be varying from 2 to 4 minutes. So in one batch you can take the 10 cups. Okay, so like our ice cream cone, you can get this type of material, and this also will have very good rigidity, and even if you apply that lecithin, soya lecithin based coating material, and it has hygroscopic in nature, so hydrophobicity will not absorb that moisture. So this type of cups also it is used in the formation of juice and other things. So this mechanical strength, all these properties, it has been evaluated. And here also some problem we identified, because these products also we have to sell it immediately. Otherwise it will also start affected by the insects. Even sometimes the rat and other things, that also will start eating. Because this, after breaking, when you throw, even that chicken will eat, even that goat we given, that will start eating. So it's a completely biomass food grade materials only. So that will be, even if you are not eating, you can throw it in environment, that will not pollute the environment. And based on the different pressures and temperatures, we evaluated these characteristics. So all which will be important, the temperature, pressure, raw material combinations, all it is important. So in such a case, whenever you are minimizing that spore space, internal spore space, then the strength of the materials will be higher, that moisture absorption which will be lesser. So that we have to standardize. And there are many companies now, they are working in this biodegradable packaging materials, and many people, they have the vision in 2030, they want to use at least 70% of the plastic they want to replace with this bioplastic materials. So many the big MLC company, they are coming forward to make such packaging materials with many R&D institutions. So you can also tie up with some industry. So even the students, when you select the project, okay, so you tie up with some industry people, talk to that industry people before finalizing your objective, and based on their request, then if you start working on it, then it will be both academia, industry collaboration which will come, and you can see your product in the commercial bigger way. Otherwise, only in the paper we can do some publications, and finally that will not be useful. And another area what we are working is 3D printing area. That is also a new area. There are many printers available. For example, these are all the advantages that you can see later also. So here what we have in our institute, it is extrusion based printing. Okay. So this extrusion based printing, when you develop a packaging material by using this 3D printing technology, okay, what will be your raw materials, what kind of that hydrogels you are using it, and what kind of geometry you are want to make it. So that is very, very important when you make it. So particularly this hydrogel, because you should have a continuous flow in the extruded. Normally our agriculture biomass material, which has that residues fiber content, you will not get the continuous flow in the extrusions. So in such a case, the optimizing the level, okay, we tried with that bran and different kinds of that hydrogel. So we made different kinds of that cups and plates, and that will be also used in the food application purpose, okay, for keeping the product. And this is another study. You can see this 3D printed aerogel based packaging material, which has the cushioning effect for your fruits and vegetables, and also it has the antimicrobial activity, so that your commodity which can, because particularly these type of things which can be used for high value commodity, because this you can't use it for tomato, brinjal. These are all the per kg also, if you buy 30 rupees, 40 rupees. So what are all the things you feel high value commodities? Sometimes you take lychee, or you take this dragon fruit. These are all the things per kg they will sell it 400, 500. So those areas, if you use this type of technology, then definitely it will be taken. So this is one product they have developed in USA. So it is 3D printed packaging material with juice items. Okay. So here what will happen, the lid also will be printed by using the 3D printing technology. So when you want to consume the product, just if you add water on the top of the lids, so then it will start the reactions and it will allow to open the lid, and it will you can get the water which will be mixed with the material, and you can consume it also. So that type of things they develop. So these type of things also you can use it in your R&D. Next is this edible packaging. This is the another area. Okay. So particularly if you see that protein based films are coming, lipid based films are coming, polysaccharide based edible films are coming. So the application side, that is you have to identify. Okay. For example, if you take the polysaccharide based film, you can use it for the dry food items. If you are selecting a protein based or a lipid based edible film, that has to be used for some dairy product or wet product. So because you have to you are developing some film, and in the application area you are doing mistake, so that you have to properly match with that. Then this is another area, it has very good potential in this. So there are many regulations are there, particularly when you talk about this 3D printing and nano. In our country, still we don't have proper regulations of usage of these things, applications in the food industries. So even if you say very minimum work which has been taking place in the nano food packaging area, even FSSAI we don't have proper regulations for this nano-based packaging material. So in such a case, still a lot of research has to be done to standardize this type of packaging material. So another thing, this nano packaging, another interesting area. You can use different kinds of nano pillars, for example, silver nanoparticle, nanoplates, metal oxide. These are all the things we are using it highly in the packaging material, particularly to improve the mechanical strength, barrier properties, antimicrobial properties. We are using these nano filler materials. You can use different applications area, particularly this area which will be used in the highly perishable commodity. Okay, if you take meat, fish, dairy product, these are all the things which will comes under highly perishable commodity. So this nanotechnology and 3D printing, this technology, you can plan for this type of highly perishable commodity, and you have a very good scope in this area. So metal nano oxide, so particularly you can see this titanium oxide, okay, silicon oxide based packaging material that will be improving that oxygen barrier properties. So wherever you feel your product will be highly oxidative, then you can use this type of metal nanoparticles, synthesized material that can be incorporated into the packaging material. So that will improve the barrier properties. Okay, PLA based nano composite materials. So this is also okay, biodegradable, and PLA with chitosan. Okay, so that will do both the function, biodegradable as well as antimicrobial properties. So you can plan, because somebody presented that crab shell, that is another huge potential area. Even if you use some green solvents to extract that chitosan or converting into chitin, so that is the thing we needed in our industrial level, because nowadays you can see that supercritical fluid extraction techniques are coming. Okay, so that is also very smaller quantity, 1 kg, 5 kg level only they are using. So what is the biomass we have, that crab? So if you standardize some green technology to minimize the energy value in those area, definitely industry will take those research output. So this is the another thing. Chitosan based nano composite, it is also available. It has a very good antimicrobial activities. Particularly you can develop some starch based film, or you can based similarly that PLA based film. And that again the drawback I told you, the continuous production machine is the drawback. So in such a case, somebody has the idea for making a continuous production film of this bio-based packaging material. So that is the another research gap we are identifying. So this alginate based nano composite, okay, that you can see that red seed, that coastal area in our country, if you see that coastal area length also very high, and we are getting different kinds of seaweeds, brown seaweed, red seaweeds, okay, that marine people, okay, that is another area you can tap. So you can collect the seaweeds, you can extract that alginate, you can add it into the nano composite material, and that is also similar to polysaccharide, and that also will give you the very good results. Even you can develop the film, you can use it for application in the fishery sector itself. Okay, so that is the another area. We have very good, similar to agriculture, we have very good biomass in the marine resources also.
So that also you can think of it. And many nano sensor is coming into the pictures, okay, particularly this intelligent packaging. You can develop some freshness indicator, time temperature indicator, okay, microbial indicator, okay. So all these things it can be do with the different kinds of intelligent packaging. So when we say this challenging, okay, so one is we don't have proper regulatory aspect, technical aspects also we are not fully driven for making this nano-based packaging materials. Industrial support, or the number of industry in our country, that is also very, very less. Particularly in the pharma industry, there are many industries are there. But if you see in the packaging industry, other food applications, very few companies they are working in this nano area. So that you can think. And similarly, if you see the packaging industry, particularly in our country, okay, we have almost now in 2025, our packaging industry turnover, you can see it was around $30 billion, okay, 30 into 100 crores. And in 2030, we are expecting it can reach up to $52 billion. So there is a very big demand which will be in the global market, and we can make a new, many wonder in this packaging area. So that is just a request from the researchers and students. So you can plan your research. That can be, it can be a patentable, it can be a published in a very good reputed peer-reviewed journal, or it has to be commercialized to support the industry. So that is in that particular area you work on it. So really you can do wonder. And this is our students, they developed using that maize corn cob. Somebody present, na? So they developed this nano film, and it can be used in the sensors as a bread packaging. And they presented in the ministry DBIIT they have conducted. So there are 2,500 people invited. After overall competition, they got a runner-up in the Geetham University. They got the prize. So the thing is, when you do good work, really automatically it can be appreciable. And these students, after this presentation, they got a chance to visit USA School of Michigan. So only they have to pay the travel cost. So other things it will be taken by DBIIT. So in such a case, you can also work on it, and you have very good opportunity in this packaging area. So with this, I conclude with my presentation, particularly the sustainable packaging, 3D printing, and even you can say nano packaging, biological packaging. So these are all the current area, many people working on it. So whenever you develop this packaging material, identify the raw material, you go in-depth study, okay? Because some people, we can do nano packaging, okay? We will put more cost in the extraction, all these things. Finally, we will get 1 milligram, 5 milligram only. That also we will apply in this fruits and vegetable packaging, all these things, that won't help. You identify the raw material where that the sources are potential, that you extract with the minimum usage of energy and cost, and that if you scale up, definitely everybody will take on your product. So with this, I conclude, and I thank the organizer for giving this opportunity. And also I request all you people, when you come to Thanjavur, visit our NIFTM Thanjavur campus also. We have facilities for the packaging and other area. So thank you very much. Sir, question. Mic.
So the DNA you have been used for developing the packaging.
Yes, sir.
So you could not extend the day because of the evolution. Then additionally you have been used ethanol.
Ethanol emitters. Because ethanol emitters, which will create the microbial, because this ethanol, when it is vaporized, it will create the environment, antimicrobial environment. Because even when we go for that laminar flow, we will clean with the ethanol to avoid that microbial contamination. So these ethanol pouches, when we keep, slowly that vapor will comes out, and that will be inside the in-pack sterilization.
My suggestion is, yes, you can go 70% isopropyl isopropyl alcohol in place of ethanol.
Methanol. Okay.
Why? Because isopropyl alcohol 70% is globally validated for is a purpose of
Antimicrobial. Okay.
which will prevent the degradation. It will extend the life of it.
Sure.
We normally use the polylactic acid sutures, which is for the absorbable sutures. When they go for the deep surgery, the first layer, second layer, third layer, the top. So the inner layer, whatever the sutures, there's stitches being done by using the PA.
Yes.
Those products, when we make the knot and keep for 6 to 3 years shelf life, there we could be able to make with the help of 70%
Isopropyl
alcohol.
Okay.
Kindly
No, we'll please.
and see the result.
No.
Definitely it will give the very good. So
Sure,
you have
sir.
been covered end to end the food packaging, including today what the industries want. Really a very good presentation.
Sure, sir.
And
Thank
a very good, insight about the complete picture about the food. This is the first presentation I could see the lot of information. So very good.
Thank you.
Second thing, the cup you made in the
Rice bran, wheat bran. Yes, sir.
Yeah. Can you open that slide?
That video.
No, cup.
Cup. You start this.
Yeah.
Yes, sir.
Here we have been suggested for keeping the cool drinks and all. Why not tea?
Sir, tea, because when it is hot,
Yeah, it will get.
it will become absorbing that moisture very quickly. So normal water which will stay.
Okay.
These
When you
hot
keep
drinks.
when you keep the cool drinks, is there any possibility to get contaminated by microorganisms? Because the material which the husk and all, there is a prone to.
It's a brown material. We tried with a different thing. One is that bamboo fiber, that and we plainly used the tapioca starch. That starch you can directly eat it. And another thing that rice bran. So here the thing is sometimes you feel that sensory when you drink, that the smell of that bran. In starch you will not get it. When you take water, you will not get any flavor of that raw material what you used. But when you take tea, when you drink, that time you will get the flavor of the bran also. So that we want to mask it. So in such a case, when we go this soya lecithin based coating, then that will then it will mask and which will retain for 20 minutes. It will. Yeah, it will. It will be there. Because it will stay. But this packet again we have to keep it in one plastic cover. Because this will absorb that moisture. Like our ice cream cone, we'll prepare the cone. It is made by maida, but it will be in a plastic cover. So to avoid that moisture absorption. Yeah, we given this technology to many people, and many people they started work. Yes, sir, it is patent. The raw material, because this raw material, just I want to tell you, after seeing these machineries and product, that Indian Institute of Spice Research, they send 25 kg of the residues. After extracting that oil from the chili, that will be the waste. After extracting pepper oil from the pepper powder, then that will be the waste. So they have tons and tons of this biomass material. So just they are putting in the same field. So they want, sir, can you make? And after making some cups, they told it can be used in the agriculture field as a nursery, seedling purpose. You can add small cups, there you can add a seed and you can grow, and this seedling directly you can keep the cup in the land, it will degrade and the plant, so no need of nowadays some plastic cup, degradable cups they are making. So instead of that you can use this type of
Horticulture and forestry, they use plenty of the bag for
sealing. So there you can use for sealing purpose.
All of the area
That we can use. Yes.
Sir, can you put that
Nano, which is like, sir? Which?
There. So the nano pillars,
Pillars,
the pillars you have been used. What was the outcome? See, you have been used zinc oxide, titanium dioxide, cellulose nanocrystals. There is various material which have been used and produced and studied. What was your outcome in that?
Sir, this is what we tried with that zinc oxide and titanium oxide. Even now this titanium oxide also they banned in USA usage of this titanium oxide. But when we try, definitely it is improving the OTR value. Oxygen transmission rate barrier, it has very good barrier properties for the oxygen transmission rate. And wherever you feel this snacks food, particularly it should not be react with the oxygen. So wherever you want to control the oxygen diffusions or oxygen reaction with the food material, there you can use this type of titanium oxide film, and particularly for the dry food item, not for the wet product. So when you have some dry product, some sweets and other thing, then it has the good effect. Yes. Yes, sir.
Zinc oxide naturally is not admissible. Zinc is which will interfere harm.
Titanium
is the biomaterial which is being used for many of the orthopedic implants that can be taken.
Yes.
That is what it is. Then here silver nanoparticle, what is that?
So silver nanoparticles, even if you buy the sweets, silver coating on the dairy product, you can see it will be there. It has the antibacterial effect.
So you have a good result on this?
Yeah, it has. But we worked on titanium and that is zinc, and now currently the student working on copper. But this silver and gold we didn't work. We'll work on it. We'll take it.
I had a good
Experience.
Silver is a very good
Very good material. It's very used.
At the same time, it prevent the infection.
Yes.
Good sir, excellent.
Okay, sir. Thank you very much, sir. No, we are all in the same fraternity. So thank you very much. Sure, sir. That is why, sir, also I told them to have collaboration, because this is the forum we can have meet each other to share, because these are all the every slide nama it has the problem. Problem means when we purchase the PLA granules, we approached one Tanjavur company to make the film. They refused. Refused means we have to stay with them for half day, 1 day to get some 1 kg, 2 kg of the film. So they said, sir, in 1 day we can produce 100 kg, 200 kg. So our total production is affected. No. Now we after that we purchased our own machine. So that is why we have a very good sustainable production unit in our campus. So when you come, you can see all bioplastic, 3D printing, these paper-based materials that we have. So any waste material you bring, that we can standardize as a packing material. So that is the thing.
So any of the food material which you have been developed,
okay.
Did we study the complete analytical properties with respect to?
Yes, sir. Sir, all these things are our PhD work only. I have taken very summarized slides only. So each area, it has been next level.
Refining the level, bring it to
Yes.
Excellent.
Yes. So thank you very much. Just I want to share you what are the problem we are facing. So what you will face it when you take research, but there is a good opportunity in this area. So thank you very much for your questions also. Thank you very much.
We are truly grateful for your time and insights. Thank you, sir. I said,
Sorry, no questions, but an appreciation. I joined Dr. Muthuswamy for his wonderful lecture. It's highly informative. Our audience, students, future entrepreneurs, it's a great information. I just want to thank you.
Please, thank you.
as a token of our appreciation, I kindly request our faculty member, Dr. J.P. Nirmala ma'am, to present a memento to our speaker, Dr. S. Anand Kumar sir. now move on to the paper presentation session for our online participants. I would now like to invite our esteemed judges, Mr. Mohammad Riasuddin sir and Mr. Krishna Subramanian sir.
Good morning, everyone. Good morning, everyone. Good morning, everyone. Good morning, everyone. I'd like to report.
ల్యాప్టాప్లో అన్మ్యూట్ కొడుతుంది వాళ్ళ జిన్సీ ఫోన్లో
హలో
Good evening to everyone present here. Good evening to everyone present here. My research work starts with my title, Development of a Pectin-based Bioactive Edible Coating with incorporation of Phyllanthus reticulus leaf extract for extension of shelf life of fruits and vegetables. A small intro of my project. In India faces severe post-harvest losses exceeding 92,000 crore post-harvest losses done due to the loss of moisture content and high respiration rate and limited cold chain infrastructure. The edible coating acts as a second skin of fruits and vegetables and prevent the spoilage from the fruits and vegetables. Then
Another, the incorporation of plant-based bioactive extracts provides natural antimicrobial and antioxidant properties to the fruits and vegetables. It prevents the fruits and vegetables from the microbial attack and water retention and microbial spoilage. Then I choose why I choose Phyllanthus reticulate leaf extract. For it is explored plant because it's a low input sourcing and also is a low cost effective and low input sourcing. It's a usable. It is beneficial for rural peoples and low scale producers. Then my main objectives of my projects to develop biodegradable packaging, bioactive edible flips based on Phyllanthus reticulate leaf extracts. It provides antimicrobial and antioxidant properties to the fruits and vegetables and prevent the fruits and vegetables from the spoilage. Then to evaluate the antimicrobial effectiveness of edible coating when it's coated into the fruits and vegetables. Then other main objectives to demonstrate the economic viability of my edible coating. Because I choose a Phyllanthus reticulate leaf extract, it's a low input sourcing and low cost effective bioactive compounds I use in edible coating. Then one of the major objectives of my project to bridge the research gap between the traditional medicinal plant uses of Phyllanthus reticulate leaf extracts and the modern food application technologies. We enter into the methodology of my project, edible coating. First, there are 5 major steps included. First of collection of material, then preparation of Phyllanthus reticulate leaf extraction. In collection of materials, I choose distilled water, food grade pectin, sorbitol, and I choose guava and banana as a self-leaf studies of my edible coating process. And preparation of Phyllanthus reticulate leaf extract, I collect the leaves from the plants and local sites, and fresh leaves as collection, washing, then dried into until drying, then grind into fine powder. Then 200 ml of water, I add 5 gram of leaf powder, and under into a boiling, I get a bioactive extraction, bioactive compounds from the aqueous extraction. Then preparation of base coatings. Preparation of base coating solution, we need a distilled water, pectin and sorbitol. In percentage of pectin used 2%, and sorbitol I choose 0.6%. And Phyllanthus reticulates, I have 2 samples are provided, on sample 1 and sample 2. On sample 1 I choose 0.4% and sample 2 0.8%. Then preparation of bioactive coating solution, add Phyllanthus reticulates leaf extract into the base coating solution. I already tell sample 1 have a 1 ml of extract and sample 2 have a 2 ml of extract, in total 250 ml of edible coating preparation. Then fruit selection and coating process. Selection of mature and uniform fruits, detect-free fruits from the local shops. Then washing, air drying, dipping in a bioactive coating solution. Then draining excess coating, drying at room temperature. And then the coating fruits and vegetables are stored in a controlled condition. And uncoated samples are controlled as a controlled samples. These are the picture I showed. Banana, in first day I coating a raw banana and raw guava. In first day I am after coating this process. Outcome of research is I divided into 2 sectors. The result of my project is pectin based and Phyllanthus reticulates infused bioactive edible coating have a better results in preservation of fruits and vegetables. It gives 2 sample 1 and sample 2. I already told sample 1 is a 1 ml of extract and sample 2 is a 2 ml of extract. Sample 2 provides better performance in preservation of fruits and vegetables better than sample 1. And then discussion and key findings. In control sample 1 and sample 2 provides a better solution and better preservation techniques in preservation of fruits and vegetables. In my results confirm the feasibility of low cost biodegradable bioactive edible coating as an alternative to synthetic preservatives, and is an alternative source of synthetic packaging, and is also a reduce the dependence of a chemical or synthetic preservatives. This is a self-life test I show in this picture. In left side, I give you a trial of, I choose a semi-unripe banana. First I coat the bananas. First I coated sample 1 and then coated sample 2, then uncoated samples. In first day the 3 samples are coated into my edible coating solution. Then 5th day the coated sample, both sample 1 and sample 2 are better in texture.
Compare then uncoated are moisture loss and color changes are occur. But 10th day in the sample 1 and sample 2 are texture is very good, but the color changes in uncoated. The uncoated samples are microbial attack is high. Compare then sample 1 and sample 2. And these studies these studies tells microbial attack in uncoated samples are high, but in sample 1 and sample 2 are any microbial attacks are done. And also a water retention and moisture loss is occurring in uncoated samples. But sample 1 and sample 2 there is no moisture loss or color change or texture and water textures are not seen in this sample 1 and sample 2. Then banana I already saw on the first day I coated the raw banana and raw guava. After the 15th day the uncoated samples are ripening and the coated and the sample 1 and sample 2 coated bananas are return its shapes and return its
அதிலே பேச சொல்கிறாங்க. அதில் பேச முடியாதா? அதில் பேசினா கேட்காதா? கேட்காதா? கேட்கல. சரி. Am I audible? Am I audible? The presentation time is 10 minutes, 8 minutes for the presentation followed by 2 minutes for the question. I would like to invite the presenter from the title Green Innovation in Packaging, review paper on natural moisture observing sachets for shelf life enhancement.
இதே போடவா? இதே போடவா? இந்த பேப்பர் அவங்க பேப்பர் ஷேர் பண்ணிக்கிறோம். இதை நான் ஆஃப் பண்ண சொல்லிட்டேன் கேமரா. அவங்க தான்க்கா ப்ரெசன்ட் ஷேர் பண்ணுங்க. அவங்க ஷேர் பண்ணுறாங்க. ஆமாக்கா. கேளுங்கக்கா, பேசுங்கக்கா.
Am I audible?
மைக் ஆன் பண்ணிட்டு பேசுங்க. ரெண்டுத்துலையும் பேசலாம்.
Am I audible? Am I audible?
கேட்கல.
Am I audible? The total presentation time is 10 minutes, 8 minutes for the presentation followed by 2 minutes for the questions. The first presentation on the title Green Innovation in Packaging, review paper on natural moisture observing sachets for shelf life enhancement from Pune Vidyarthi Griha College of Engineering and Technology. Unmute பண்ணுங்க. Unmute
அன்மியூட்டில் தான் இருக்கு எல்லாமே.
இல்லை அவங்க பேச நம்ம இதில் கேட்கல, ஸ்பீக்கர் கேட்கணும். அவங்க பேச
ஓகே ஓகே, இப்போ நான் ஆன் பண்ணிட்டேன்.
சரி ஓகே. எனக்கு வந்து உட்காந்து பேசுறது
பேசுகிறாங்களா?
இப்போ பேசுகிறேன்.
ஓகே பேசுகிறேன்.